Hello all. In this video we'll explore stereochemistry with RDKIT, that's associated kit that contains all of the details of organic chemistry compounds that you can use directly with Python itself. And my name is Abhishek Nandi. I'm a PhD scholar. My specialization is in bioinformatics AI. I'm also a chief data scientist at Predict Business Solutions Private Limited. So let's start with the journey. So what are stereoisomers? So stereoisomers are molecules that have the same molecular formula and sequence of bonded atoms but differ in three-dimensional orientation of atoms in space. So what we are trying to achieve is we'll show the different kind of stereoisomers using Python, using a visualization library called Streamlit that's very popular. So what we are trying to achieve, stereochemistry using Python, Streamlit and RDKIT. That's our primary goal. We'll set up Streamlit, import Streamlit and use its function to create user inputs. This will be done using Python itself. User input for smile string, allow the users to input the smiles. So smiles are the ways we pass in the chemical compounds or the structure of a particular molecule, and we deal with the changes that happens. So these reactions that you see as a visualization pattern would be done with the help of the input from user. So molecular visualization, use RDKIT for molecule generation and Streamlit Chem for visualization or similar libraries. But we are using Streamlit itself, so that would be it. Stereoisomer generation and display, generate and display stereoisomers based on the input file strings that we passed. So we'll create the web interface sets. So what exactly it does, that using the streamlit.title, the line that is there for code itself in Python, it sets the title of the app displayed on the page. Then streamlit.text input creates an input box for the user to enter a smile string. It's pre-filled with a compound, like we have passed in a particular compound. You can change it. We'll see how to change it, and we'll use some complex smiles format for our usage. Then we'll process the smile string. So using this particular code pattern itself from RDKIT, we are using chem.mol from smiles user smiles, converts the user entered smile that we are passing string into a molecular object using RDKIT. Then we can check the validity of the molecule and display the original molecule itself, generate and display stereoisomers, enumerate stereoisomers, generate stereoisomers of the given molecule on specified options. The app then iterates through stereoisomer, converts them to smiles format, generates their images and displays them. Okay, so let's move into the code right now. So I have all of my setup done in D drive itself. We'll go to the place where I've written the code. Here it is in the stereochemistry option. Just go through it. It's there in stereochemistry. So first I tried with simple Python, and then I moved to the Streamlit option itself. To see the proper working of a code, or how it behaves, I have installed and I do all my IDE work using Visual Studio Code. So if I initiate code space dot, it opens. So as I mentioned, I have imported Streamlit, RDKIT, and also this enumerate stereoisomers, as we are working with stereoisomers and we are drawing the molecule. We are taking the user input, then converting a smile to molecule, and smile strings that is being passed, convert smiles to molecule and check if the molecule is valid. If it is valid, then we are showing the image. Otherwise, we are using an error handling method that says that invalid smile string, please enter a valid smile. So to initiate the program, what we need to do is you have to pass in Streamlit space run, and then the file that is str2.py. Okay, so I haven't initialized my conda environment. I will do that. Conda activate py 310, where I have all the supportive libraries installed. Okay, So now I'll run the command. It will open up the interface on web. You will see it working. You see right now the original molecule and the stereoisomers for it. Okay, so now if you want to see some complex utilization, here is one caffeine. Caffeine is a well-known stimulant found in coffee and tea. We'll see how it works. I will just put it in over here. Let's see if this works or not. I will pass and enter. You see the original compound and the stereoisomers for it. Okay, now similarly I change it. I will use penicillin. Penicillin is a group of antibiotics derived from penicillin fungi. The smile is this, one of the most commonly used penicillins. Okay, so we'll just pass in this particular parameter and see like if it works or not. I have passed in, pressed and enter. I see penicillin stereoisomers also being created. Very useful tool. And let's see for cholesterol itself. Cholesterol is a type of lipid molecule and biosynthesized by all animal cells. It is an essential structural component of animal cell membranes. So we have vitamin B112 here, B12 that is there. This is a big compound. Let's see this also works or not. Okay, so we'll pass in B12. Now enter. It says the compound might be there's some issue. The validity of the smiles is not working. Probably the length of it might not work. Let's take another example itself, because I am trying it for the first time. 2. Okay, I'll just copy it and pass it along. Press enter. You see the stereoisomers. It's running through. It will create just a little bit of time. It will take time. It's parsing. See, it's showing trying to parse, but there are some errors. So that happens in general. So we see like it's a tried and tested technique. Some of the things work, some of them might not work, but we have started building on top of this. I'll try to improvise on the the code that is being shown and why these results are being coming up, and I will try to improve. But it's a first-hand experience that we have tried, and we can see different kind of compounds. We'll just stop it right now. I'll try to use another compound. Let's see if this works or not. This is also a big compound. If you can use some mild ones or the smaller ones like this comes up. Bigger compounds I need to check. Sorry, we have the structures and stereoisomers for this. Let's see if this works or not. Yeah, so the length might be a factor. I'll check on it and I will come up with a better version next time. But the code is here. I will share it in GitHub. You can check and also work with it. Thank you.